The stars have always whispered secrets, but rarely do they send a messenger as enigmatic as 2I/Atlas, an interstellar comet streaking through our solar system, carrying whispers of life from beyond. On this crisp September day in 2025, humanity stands at the edge of a revelation, captivated by the faint glow of an object that defies everything we thought we knew about the cosmos. The James Webb Space Telescope, humanity's most powerful eye into the universe, has turned its gaze from the distant echoes of the Big Bang to a visitor much closer to home, one that may hold the key to answering whether we are alone. This is not just a story of science, it's a tale of wonder, unease, and the tantalizing possibility that life is not Earth's alone, but a universal force, carried on icy wings across the vastness of space. As 2I/Atlas draws nearer, its secrets unravel, pulling us into a narrative that could reshape our place in the cosmos. Imagine a solitary traveler born in the fires of a distant star, flung into the cold void of interstellar space millions of years ago. This is 2I/Atlas, only the second interstellar comet ever identified, a cosmic wanderer that entered our solar system at a blistering pace, its trajectory a silent testament to its alien origins. Unlike the comets that orbit our sun, born in the icy nurseries of the Kuiper Belt or Oort cloud, 2I/Atlas hails from a star system we may never see. Its discovery in 2019 was a triumph, but it was the James Webb Space Telescope's observations in 2025 that transformed it from a curiosity into a phenomenon. As Webb's infrared instruments pierced the comet's glowing coma, a halo of gas and dust illuminated by the sun's warmth, they revealed something astonishing: spectral signatures that didn't align with the inert rock and ice of typical comets. Instead, they hinted at complex organic molecules structured in ways that echoed the building blocks of life. These weren't just random chemicals scattered in cosmic frost. The patterns were too ordered, too deliberate, resembling the carbon-based chains of amino acids and lipids found in living organisms on Earth. Each observation, meticulously confirmed across multiple angles and wavelengths, deepened the mystery. Scientists accustomed to the sterile predictability of celestial mechanics found themselves grappling with data that suggested something alive, or at the very least lifelike, within the comet's frozen heart. The implications are staggering. If 2I/Atlas carries biological material, it could be the first direct evidence of panspermia, the theory that life's seeds are scattered across the galaxy by comets and asteroids. This lone traveler, drifting for eons through the emptiness of space, might be a cosmic courier, delivering proof that life is not a fluke of Earth, but a universal phenomenon, sprouting wherever chemistry and energy collide. As 2I/Atlas approaches the sun, its behavior grows stranger, as if it's awakening from a long slumber. The comet's coma pulses with irregular jets, not the uniform haze expected of sublimating ice. These rhythmic bursts, observed by Webb and corroborated by ground-based telescopes, seem almost timed, like the exhalations of a living system. Nitrogen compounds, oxygen isotopes, and fleeting emission patterns suggest processes beyond simple geology, processes that mimic the byproducts of metabolism or respiration. The comet's surface, warming under the sun's gaze, resists the fragmentation that tears apart lesser bodies, hinting at an internal strength that defies explanation. Could there be hidden reservoirs of liquid water beneath its icy crust, warmed by radioactive decay or ancient tidal forces? Could these pockets harbor microscopic ecosystems, preserved in a deep freeze until the sun's heat stirs them to life? The data paints a picture of a comet that is not merely a relic, but a dynamic system, maintaining itself against the ravages of space. Its isotopic ratios, particularly the depletion of certain carbon and hydrogen isotopes, align with patterns seen in Earth's biosphere, where life fractionates elements through metabolic processes. Even the comet's magnetic field, unusually strong for such a small body, raises questions. Could it be linked to magnetically sensitive compounds, like those in Earth's magnetotactic bacteria? The colors of its coma, faint greens and reds from tholins and other organic polymers, add to the enigma, suggesting a chemistry poised on the edge of biology. Each new observation, from Webb spectrographs to radio telescopes scanning for molecular signals, builds a case that 2I/Atlas is more than a cosmic snowball. It's a potential arc of alien life. The discovery of 2I/Atlas forces us to rethink the boundaries of life. For decades, the search for extraterrestrial biology focused on planets and moons. Mars' dusty plains, Europa's icy oceans, or distant exoplanets orbiting faraway stars. But a comet, a fleeting visitor from another star system, changes the equation. If life or its precursors can survive the interstellar void, protected within icy cocoons, then the universe may be far more alive than we imagine. The panspermia hypothesis, once a speculative idea, gains tangible weight. Perhaps Earth's own life began with a similar traveler, a comet carrying microbial seeds that sparked our biosphere billions of years ago. 2I/Atlas, with its lifelike signatures, could be a mirror reflecting our own origins, a reminder that we are part of a cosmic tapestry woven across light years. The comet's origins are as mysterious as its composition. Was it ejected from a living world, a fragment of a biosphere torn apart by a cataclysmic event, or did life emerge within its icy interior, nurtured in hidden lakes warmed by faint heat sources? Either scenario rewrites our understanding of biology's reach. A planetary origin suggests ecosystems thriving in distant star systems, their remnants scattered like cosmic pollen. A cometary origin implies life can arise in environments we once dismissed as barren, making every icy body a potential cradle. As 2I/Atlas draws closer, its increasing brightness offers richer data, each scan peeling back layers of its story. Scientists worldwide are mobilizing, from observatories in Chile to radio arrays in Australia, all united in decoding this interstellar message in a bottle. The implications of 2I/Atlas ripple beyond science, touching the core of human curiosity and responsibility. The possibility of alien biology, even microbial, raises questions of contact and contamination. While the comet poses no collision risk, its dust could drift into Earth's atmosphere, carrying unknown biochemistry. Planetary protection protocols designed for Mars rovers and lunar landers now face a new challenge: how to handle material from a star system we know nothing about. Yet, the overwhelming emotion is not fear, but awe. For astronomers who spent decades building Webb, this discovery is a vindication of their dreams, a gift from the cosmos that arrived sooner than expected. For the public, it's a story that ignites the imagination, blending mystery with the primal question of our place in the universe. The comet's passage is a fleeting opportunity, a brief window to capture its secrets before it swings past the sun and vanishes into the void. Observatories are coordinating like never before, with amateurs joining professionals in a global effort to track its every move. Conferences buzz with debates, from cautious interpretations of exotic chemistry to bold claims of alien biology. Artists paint its eerie glow, writers weave tales of cosmic kinship, and philosophers ponder whether life's universality makes us less unique or more connected. 2I/Atlas is not just a scientific object, but a cultural touchstone, a catalyst for reflection on what it means to be human in a cosmos that may teem with life. As 2I/Atlas carves its path through the inner solar system, it performs a cosmic symphony, each note a revelation that resonates across disciplines and cultures. The comet's behavior defies the simplicity of a frozen relic, its rhythmic jets and stable nucleus suggesting a complexity that feels almost orchestrated. Webb's data reveals thermal anomalies, subtle fluctuations in temperature that hint at internal processes, perhaps the cycling of heat through hidden cavities where liquid water might persist. These pockets, if they exist, could be microcosms of life, shielded from the cosmic radiation that bathes the comet's surface. The idea that such a small, transient body could harbor ecosystems, however primitive, challenges our understanding of habitability. It suggests that life's tenacity is not bound to planets, but can endure in the most unlikely of places, carried across light years by the silent momentum of gravity. The comet's magnetic field, stronger than expected, adds another layer to this symphony. Its fluctuations hinting at structures or compounds that align charged particles in ways that echo Earth's own microbial adaptations. Scientists speculate about magnetotactic-like processes, where microscopic systems might orient themselves to cosmic fields, a phenomenon that feels both alien and familiar. The comet's coma, with its greenish-red hues, pulses with a rhythm that mirrors biological cycles, its emissions carrying traces of nitrogen and oxygen isotopes that defy geological explanations. This is not just a comet, but a storyteller. Each burst of gas and dust a chapter in a narrative written in the chemistry of distant stars. As observatories worldwide train their lenses on 2I/Atlas, they capture a performance that feels like a dialogue between humanity and the cosmos, a conversation that began eons ago and is only now reaching our ears. The global scientific community, from astrophysicists to biochemists, collaborates with a fervor rarely seen, united by the possibility that this interstellar visitor is not just a relic, but a living testament to life's universality. The data streams in, each byte a note in this cosmic score, urging us to listen closely and imagine a universe where life is not an exception, but a rule, played out in the silent dance of comets across the galactic stage. The journey of 2I/Atlas is a bridge between the present and an unfathomably distant past, a relic of a star system that may have burned brightly when Earth was still a molten infant. Its trajectory, calculated with precision by astronomers, suggests it was ejected from its home system millions, perhaps billions of years ago, carrying with it the chemical fingerprints of its birthplace. The isotopic ratios in its water and organics, distinct from those of our solar system, point to a stellar environment with unique conditions, perhaps a star richer in heavy elements, or a planetary system sculpted by violent upheavals. If 2I/Atlas carries life or its precursors, it could be a fragment of a biosphere that flourished long before humanity's ancestors crawled from Earth's oceans. This possibility transforms the comet into a time capsule, its icy layers preserving a snapshot of a world we may never visit. The idea that it might have originated from a living planet shattered by a cosmic collision or stellar explosion evokes a sense of kinship across the ages, a reminder that life, wherever it arises, is bound by the same universal chemistry. Alternatively, the comet's internal warmth, possibly sustained by radioactive isotopes or ancient tidal heating, could have fostered life within its own structure, a self-contained ecosystem drifting through the void. Such a scenario stretches the imagination, suggesting that life's spark can ignite in the most transient of homes, nurtured by the faintest glimmers of energy. The comet's resilience, its ability to withstand the stresses of solar heating without fragmenting, hints at an internal architecture that may have been shaped by these processes, binding its materials in ways that defy the fragility of ordinary comets. As scientists analyze its spectral lines, they uncover patterns that suggest not just chemistry but organization, molecules that resist degradation, emissions that pulse with regularity, and isotopic signatures that whisper of biological fractionation. These echoes from a distant past resonate with our own story, raising the possibility that Earth's life may share a common origin with whatever 2I/Atlas carries. The comet becomes a mirror, reflecting not just the chemistry of another star, but the potential universality of life's narrative, a story that binds us to the cosmos in ways we are only beginning to comprehend. The arrival of 2I/Atlas is more than a scientific milestone. It is a catalyst for humanity's future, igniting dreams of exploration and redefining our ambitions in the cosmos. The comet's fleeting passage through our solar system, a brief encounter on its endless journey, has sparked a global movement to prepare for the next interstellar visitor. Space agencies, from NASA to ESA to emerging players like India's ISRO, are drafting proposals for rapid response missions. Spacecraft designed to intercept and study comets like 2I/Atlas up close. These missions, still in their infancy, envision probes equipped with drills, spectrometers, and sample return capsules capable of capturing fragments of alien material for analysis on Earth. The technological challenges are daunting. Intercepting a high-speed object requires precision and speed beyond current capabilities, and analyzing potential biology demands protocols to prevent contamination of both Earth and the sample itself. Yet the promise of holding alien life in our hands drives innovation, pushing engineers to rethink spacecraft design and propulsion. Beyond technology, 2I/Atlas has galvanized a cultural shift, inspiring a new generation to look skyward with wonder and purpose. Schools and universities report surging interest in astronomy and astrobiology, as students grapple with the implications of a universe teeming with life. The comet's story has permeated art and literature, with novels imagining civilizations born from cometary planetary seeds, and films depicting humanity's first contact with an interstellar traveler. Philosophers and ethicists debate the responsibilities of encountering alien biology, questioning how we balance discovery with caution. The comet has become a symbol of unity, drawing together diverse fields and nations in a shared quest to understand its secrets. As 2I/Atlas approaches its closest point to the sun, its increasing activity offers a final burst of data, a treasure trove that will fuel research for decades. This moment, captured by the collective gaze of humanity's telescopes, is a turning point, a reminder that exploration is not just about answering questions, but about embracing the unknown. 2I/Atlas has shown us that the universe is alive with possibility, and as we chart the path forward, we carry its legacy, a call to explore, to question, and to connect with the cosmic story that binds us all. The enigma of 2I/Atlas extends beyond its chemical composition or physical anomalies. It speaks to a deeper truth about the nature of the cosmos itself, whispering that life may be an intrinsic feature of the universe, woven into its very fabric. As the comet sweeps closer to the sun, its coma expands, revealing new layers of complexity that challenge our understanding of what constitutes a habitable environment. The rhythmic pulses of its jets, observed with unprecedented clarity by the James Webb Space Telescope, suggest a cyclical process that defies the chaos of sublimating ice. These bursts, occurring with a regularity that feels almost deliberate, evoke comparisons to biological rhythms on Earth, processes like cellular respiration or the pulsing of microbial colonies responding to environmental cues. The presence of tholins, those complex organic polymers that tint the comet's coma with reddish hues, points to a chemistry rich with prebiotic potential, a stepping stone toward life that could have been activated in the warmth of a distant star or within the comet's own hidden reservoirs. The isotopic signatures, with their telltale depletions of certain elements, align with patterns seen in Earth's biosphere, where life's processes selectively favor lighter isotopes, leaving a chemical fingerprint that is hard to dismiss as mere chance. Even the comet's magnetic anomalies, detected as subtle deflections in its coma's charged particles, hint at structures or compounds that could be organized in ways that mirror life's adaptability. The possibility that 2I/Atlas harbors microbial ecosystems, dormant or active, forces us to reconsider the boundaries of habitability, suggesting that life may not require the stable conditions of a planet, but can persist in the transient, frozen interiors of comets drifting through the interstellar void. This revelation transforms our view of the cosmos from a sterile expanse of stars and gas into a living tapestry, where every icy body could be a potential carrier of life's seeds, waiting for the right moment to awaken. The global scientific community, galvanized by this prospect, has poured resources into analyzing every facet of the comet's behavior, from its thermal fluctuations to its spectral emissions, each data point a thread in a narrative that connects Earth to the broader universe. Amateur astronomers too have joined the effort, their backyard telescopes contributing to a collective vigil that spans continents and cultures, a testament to humanity's shared curiosity. As 2I/Atlas continues its journey, it challenges us to see the universe not as a distant frontier, but as a living, breathing entity where life's whispers echo across the stars, waiting for us to listen. The story of 2I/Atlas is a profound reminder of our interconnectedness with the cosmos, a narrative that weaves humanity into a larger tapestry of life that spans galaxies and epochs. The comet's journey, spanning millions of years and light years, is a testament to the resilience of the materials it carries, materials that may hold the key to understanding life's origins not just on Earth, but across the universe. If 2I/Atlas indeed harbors biological signatures, it suggests that life is not a solitary phenomenon confined to our pale blue dot, but a universal force, capable of emerging in the most unlikely of places and enduring the harshest of journeys. The comet's isotopic anomalies, with their hints of biological fractionation, evoke a sense of kinship with whatever processes shaped its chemistry, whether in the oceans of a distant planet or the warm cavities of its own icy heart. The idea that Earth's life may have been seeded by a similar interstellar traveler adds a layer of intimacy to this discovery, suggesting that our biosphere is but one branch of a cosmic tree, its roots stretching back to the stars. This sense of kinship extends beyond science, touching the realms of philosophy, spirituality, and culture, as humanity grapples with the implications of a universe teeming with life. The comet's eerie glow, captured in paintings and photographs, has become a symbol of this connection, a beacon that draws artists, writers, and thinkers to explore the idea that we are not alone, but part of a vast living cosmos. Religious traditions, too, find resonance in this discovery, seeing in 2I/Atlas a reflection of creation's boundless potential, a reminder that life's spark may be a divine gift shared across the stars. The global response to the comet has been a unifying force, with scientists, educators, and enthusiasts collaborating in ways that transcend borders and ideologies, all drawn together by the shared wonder of this interstellar visitor. As 2I/Atlas approaches its perihelion, its brightest moment in our skies, it serves as a mirror reflecting our own aspirations and responsibilities as stewards of a living planet. The comet's passage, brief though it may be, invites us to see ourselves not as isolated beings, but as participants in a cosmic narrative, one that binds us to the distant worlds and ancient processes that shape the universe's story. This tapestry of kinship, woven from the threads of chemistry, curiosity, and imagination, reminds us that our journey is not solitary, but shared, a dance of life that echoes across the stars. The arrival of 2I/Atlas marks the dawn of a new era in human exploration, a moment when the boundaries of possibility are redrawn by the light of a single comet. The data pouring in from the James Webb Space Telescope, combined with observations from ground-based observatories and radio arrays, has ignited a global push to prepare for the next interstellar visitor, a mission that could redefine our relationship with the cosmos. Engineers and scientists are dreaming big, conceptualizing spacecraft capable of chasing down objects like 2I/Atlas at speeds that defy current technology, equipped with tools to probe their interiors and return samples to Earth. These missions, though years in the making, are fueled by the urgency of this moment, as the comet's lifelike signatures underscore the need to act swiftly when such travelers pass through our solar system. The challenges are immense. Intercepting a high-speed comet requires propulsion systems that can match its velocity, navigation systems that can track its unpredictable path, and instruments that can analyze alien materials without contamination. Yet the potential rewards, direct evidence of extraterrestrial biology, drive a level of innovation unseen since the Apollo era. Beyond the technological frontier, 2I/Atlas has sparked a cultural renaissance, with educational programs springing up to inspire students to pursue careers in astrobiology, astrophysics, and space engineering. Museums and planetariums are hosting exhibits that bring the comet's story to life, using interactive displays to simulate its journey and the chemistry of its coma. The public's imagination has been captured, with social media buzzing with discussions about the comet's implications, from speculative theories about alien ecosystems to heartfelt reflections on humanity's place in the universe. This moment has also prompted a re-evaluation of planetary protection protocols, as the possibility of alien microbes raises questions about how we safeguard Earth while respecting the integrity of extraterrestrial life. International committees are convening to draft guidelines for future sample return missions, ensuring that any contact with alien biology is handled with care and responsibility. As 2I/Atlas continues its journey, its legacy is already taking shape, inspiring a new generation of explorers to reach for the stars. The comet's passage is a call to action, a reminder that the universe is not a distant abstraction, but a living, dynamic realm that invites us to explore, to discover, and to connect with the wonders that await. This new era of exploration, sparked by a solitary comet, promises to carry humanity forward into a future where the cosmos is not just observed, but embraced as our home. The resilience of 2I/Atlas, as it withstands the relentless forces of the solar system, sings a silent song of endurance that captivates scientists and dreamers alike, echoing the tenacity of life itself across the cosmos. Unlike many comets that fracture under the sun's intense heat, 2I/Atlas holds its form, its nucleus unyielding despite the violent outgassing that sends plumes of gas and dust spiraling into space. This structural integrity, observed through the keen eyes of the James Webb Webb Space Telescope suggests an internal architecture far more complex than the loose conglomerates of ice and rock that characterize most comets. Could this stability be the result of chemical or biological processes that bind its materials, creating a matrix capable of resisting the stresses of solar radiation and gravitational tides? The comet's thermal properties add to this mystery, with temperature fluctuations that hint at internal heat sources, perhaps pockets of radioactive decay or residual energy from ancient encounters with massive planets in its home system. These anomalies suggest the possibility of subsurface environments where liquid water, the cradle of life as we know it, might exist, sustaining microbial communities or prebiotic chemistry in a state of suspended animation. The rhythmic jets, pulsing with a cadence that defies random sublimation, evoke the image of a living system breathing in response to the sun's warmth, each burst releasing molecules that carry the faint signature of metabolic processes. The presence of complex organic compounds, including amino acids and lipid-like structures, detected in the comet's coma, points to a chemistry that is not merely reactive but organized, as if guided by an unseen hand towards self-preservation. This resilience extends beyond the physical to the philosophical, challenging us to consider whether life's ability to endure the harshest conditions of interstellar space is a universal trait, a testament to its adaptability and persistence. The global scientific effort to study 2I/Atlas has become a symphony of collaboration, with researchers from diverse fields, chemists analyzing molecular bonds, physicists modeling thermal dynamics, and biologists hypothesizing about microbial survival, working together to decode this song of resilience. Amateur astronomers equipped with powerful backyard telescopes contribute observations that add depth to the narrative. Their passion, a reminder that this discovery belongs to all of humanity. As 2I/Atlas continues its journey, its silent song resonates, a melody of endurance that speaks to the possibility that life, in all its forms, is built to survive the cosmic odyssey, waiting patiently for the right moment to awaken and sing. The arrival of 2I/Atlas has ignited a global fire of curiosity, transforming it into a beacon that draws humanity together in a shared quest for understanding, a light that pierces the darkness of our cosmic ignorance. This interstellar visitor, with its tantalizing hints of alien biology, has transcended the boundaries of science, becoming a cultural phenomenon that inspires awe and unity across the globe. From bustling cities to remote observatories, people are turning their eyes skyward, captivated by the possibility that this comet carries evidence of life from another star system. The James Webb Space Telescope's data, streaming in with each passing day, has become a shared treasure, with open access datasets allowing researchers, students, and enthusiasts to delve into the comet's mysteries. Universities are hosting webinars and symposiums, where astrophysicists debate the implications of the comet's isotopic ratios, while poets and musicians draw inspiration from its ethereal glow, crafting works that capture the wonder of this cosmic encounter. Social media platforms buzz with discussions, from speculative threads about alien ecosystems to heartfelt posts about humanity's longing to connect with the cosmos, creating a digital tapestry of collective curiosity. Educational initiatives have surged, with schools integrating the comet story into curricula, teaching students about spectroscopy, astrobiology, and the history of cometary science, fostering a new generation of explorers. The comet's cultural impact is evident in art galleries, where exhibitions showcase its eerie green and red hues, and in theaters, where documentaries trace its journey from a distant star to our solar system. This collective curiosity extends to the ethical realm, as thinkers grapple with the implications of discovering alien life, debating how humanity should approach such a profound encounter with humility and respect. International organizations, from the United Nations to space agencies, are convening to discuss the implications of 2I/Atlas, not just for science, but for global cooperation, recognizing that this discovery demands a unified response. The comet's passage has become a rallying point, a moment when humanity's diverse voices, scientists, artists, educators, and dreamers, join in a chorus of wonder, each contributing a note to the song of exploration. As 2I/Atlas nears its closest approach to the sun, its brilliance in our skies serves as a beacon, reminding us that curiosity is our greatest asset, a force that unites us in the pursuit of knowledge and connection with the universe. The legacy of 2I/Atlas will endure long after it fades from view. Its data will fuel research for years, shaping theories of life's origins and distribution. Already, engineers dream of missions to intercept future interstellar visitors, spacecraft equipped to drill into their cores or return samples to Earth. The technological hurdles are immense, but the reward, holding alien biology under a microscope, drives innovation. For now, we rely on Webb's unblinking gaze, its data pipeline delivering revelations with every pass. Each new finding, from rhythmic plumes to isotopic anomalies, deepens the sense that we are witnessing something profound, a moment when humanity's gaze meets the universe's secrets. As 2I/Atlas continues its journey, it carries more than molecules. It carries our hopes, fears, and questions. Is life a cosmic inevitability, sprouting wherever conditions allow? Or is this a rare glimpse of something fragile, a spark that flickered in a distant star's embrace? The comet's silent passage binds us to a larger story, one where the universe conspires to reveal its truths when we are ready to listen. It reminds us that exploration is not just about reaching new places, but about embracing the unexpected, the strange, the alive. As we stand on this precipice, guided by the light of a telescope and the silent approach of a comet, we are reminded that the universe is vast, strange, and perhaps more familiar than we ever dared to dream. So let's keep watching, keep questioning, and keep reaching for the stars, because the next chapter of this cosmic story is just beginning.